All right, we've been talking a lot about heat. Now we're going to talk about enthalpy, which is a way that we measure heat. But it's not really, so Q is measuring the actual heat of the system, so how much it literally has. Enthalpy, though, is a measurement of the change of heat. And so what it tells us is the heat released or absorbed by a chemical reaction. So remember, delta is always final minus initial. And since when we talk about reactions, it is reactants turning into products. That means products are our final, reactants are our initial. So a way to think about delta H is the enthalpy of the products minus the enthalpy of the reactants. And when we talk about enthalpy, we use the term heat, but remember, heat does not necessarily mean hot. So the heat of the products, or the energy of the products, minus the heat of the reactants, or the energy of the reactants. And when we subtract those two values, what we get is either a positive or a negative number, and that tells us if the heat, if energy is released or absorbed by the reaction. So an example to think about this then would be hydrogen fuel. So there's a lot of talk about hydrogen fuel cell cars or burning hydrogen because it's a lot more environmentally friendly than the fossil fuels we use now. The byproduct, instead of being carbon dioxide, is instead water. So if we were to burn hydrogen fuel cells in our cars, we would use H2 reacted with oxygen to generate H2O. This process, the change in enthalpy, would be negative 572. That's because energy built into these bonds is being released in the form of heat energy. And so it would be a negative number or an exothermic process. Now, if we were to do this backwards, so in order to make the H2 gas, we would have to take water and break its bonds into H2 and O2. Since this is backwards and we're after putting energy into the system, it becomes an endothermic process. And notice how the magnitude of these two are exactly the same. If it releases 572 kilojoules of energy, that means you have to put in 572 kilojoules of energy. And this is what actually makes hydrogen fuel cell cars so inefficient, because you have to put the same amount of energy into it that you get out. So in order to generate that hydrogen gas, you'd have to put energy in, and where do you get the energy to put in? By burning fossil fuels. And so really you're just burning gas to make a cleaner gas, and so it comes out as not really a good idea. So this goes for any process. The magnitude, whether it be the endothermic or the exothermic, forwards or backwards, is always going to be the same. So in order to generate water from H2 and O2, it would be negative 572. That process right there would be exothermic. We can write any reaction, flip-flop them, and it would be an endothermic process where we change it by putting energy in. And we could double, triple, or quadruple this value by double, tripling, or quadrupling the amount of reactants in it. So if we were to triple the amount of water that we were turning into H2 and O2, that means we would have to triple the amount of energy that we put in. Or if we were to triple the amount of H2 and O2 that we were burning, we would triple the value of the energy that's being released. Alright, enthalpy is the name of the game for this unit, and there's really 4 ways to find enthalpy. And we're going to go through in the different slides, different videos, and talk about all 4 methods. Now, it's important that you understand each individual method as it is written, because you're not going to be given a question where they say, hey, calculate the enthalpy by using a calorimeter. They're going to give you certain sets of data, and you have to then pick, okay, hey, I've got a couple different enthalpy values. I'm going to use Hess's law, or I'm going to use enthalpy of formation. So it's a decision you have to make on your own because you understand the material.